Welcome to IIIF Week. That's a hashtag that we've been using. So by all means, please use that if you see fit. We're using the Zoom webinar mode. And so by default, everyone is muted, just given the size of the audiences and the response that we've had. It's kind of the only way that we can make this work in such ways, such large sets of folks. But we really do, I think, want to have some conversation and encourage questions. So there's a Q&A functionality that you'll see at the bottom of your interface. So by all means, put those questions in there, and someone other than me will be answering those questions for you. Aside from that, we do have a little bit of a back channel on the IIIF Slack, totally optional. If you are a Slack user, then great. Somebody will put the link real quick into the chat so that you can join that if you're interested. And the last thing I'll say is that we are recording this session, and that's so that folks in other time zones who couldn't be here now can also see this and kind of hear the updates. So keep in mind that we're recording this, and we'll make the links of those recordings available to you as soon as we are able to process that. So following this week, look for those on the website, and if you registered, you should get an email about that as well. So let me stop the boilerplate there, and I will now hand it over to your capable hosts and panelists. I guess first I'll toss it to you, Elliot, and you can take it from there.
Thank you, Josh. Hello, everyone. Welcome to the IIIF Maps Showcase. My name is Elliott Jordan. I'm a software developer at Princeton University Libraries. I'm also one of the co-chairs of the IIIF Maps Community Group, along with Bert, Spaan, and Stace Maples. The IIIF Maps Community Group was chartered in mid-January of this year and was solidified during an early in-person meeting at Stanford University. Out of that meeting, a number of use cases were developed, which identified two main themes or tracks for the group. The first is geolocation of IIIF content, and the second is implementing georeferencing functionality around historic maps. To that end, we are currently in the process of chartering a technical specification group to work on adding geo-support to version 3 of the presentation API. If any of this is interesting to you, or if anything that you hear today is interesting, please feel free to join our bi-weekly Wednesday calls at 3 o'clock GMT. We typically announce the agenda for the meeting several days beforehand on the IIIF Discuss email list. So today we'll see a couple of presentations, each roughly aligned with one of the community group's two themes. First, we'll have Bryan Haberberger, who will discuss using web annotations for geolocation in a IIIF manifest, and then give a simple demo showing step-by-step web annotation creation using a leaflet-based application that he's put together. And then Bert will introduce maps and humanities and how this led to the formation of the IIIF Maps group, as well as demo some of his work on image georectification. If you have questions, as always, please type them into the Q&A window, and we'll do our best to address them at the end of the presentation. And with that, I'll turn it over to Bryan.
Hi, can you guys hear me? I'm gonna kind of assume yes. I'm Bryan Haberberger. I work as a full stack developer at St. Louis University. I sort of jumped in and started with the mapping groups because of a project I'm working on there called the Live Religion in the Digital Age project. Here, I'm gonna try to share my screen if it'll let me. There we go. Which you can find at religioninplace.org. Essentially, it's a linked open data challenge that brings together people, places, objects, and events, and sort of how they're loosely connected, with an aim to sort of describe how a region shaped a religion, or how a religion shaped a region. So the scope of it is a little bit outside of IIIF. There's a lot of resource types that it doesn't encompass that aren't within the IIIF scope that it's using. But in particular, in the project, I'm doing web annotation to put geolocation onto all the data points. One of the things that we're very concerned with from the start was anything I upload, an event, a person, and an object, or anything I come across, I want to be able to provide a point on a map for where it came from or where I found it or where I know that it's at. So I have to further describe all of those objects using GeoJSON LD web annotations. So like I said, since web annotations under the scope of IIIF, if you went to their presentation API, you would see here where it describes sort of how to use annotations. And this is where I got the sort of syntax for the examples I'm going to show. Hi, Bert. Anyway, I have a demo that's up and ready to go. If you go to geo.rerum.io, it gives you a way to sort of go through and make your own geographic assertion on what should be a IIIF object. So what that might look like is if I come in here and I say, okay, I'm going to target something in the world. So I'm going to target this Vatican Library book that I know is at the Vatican Library. I'll go out and resolve it and let you know that's a URI that's good and you can use it. So I do want to use that URI, and then I happen to look up coordinates ahead of time, so I'm going to cheat a little bit here. You could use this interface to left click and select a point and then say I want to use that, or you can sort of know your own coordinates on the side. So I already did this, like I said, ahead of time, so I'm just going to cheat. So it's that simple. I just need to have a target and a place where I want to geolocate it to. And then I say I do want to do that. And now here's what that web annotation actually looks like. You'll see it's under the IIIF context and the GeoJSON LD context. And it's as simple as it can be, right? It's just the coordinates for a point, which is probably the least exciting thing. But to get the first sort of recipes through, we try to keep with things as simple as possible. So I can say I do want to create that. And that happened really fast. All right, server's working today. So now if I've actually created that annotation, you save that into Rerum, which is sort of a dev space or a dev space in Rerum that I have. That's an annotation store. So what I do is I have a leaflet viewer that asks for the geographic assertions out of that store. And you'll see here that object I just targeted, and it knows its label. I couldn't find a description, but it has the annotation and the target fully in there if you ever wanted to go look at it and just make sure you targeted the right thing. So a really simple demo. That's all that does, and it's just a way to show you sort of how simple making the assertion of I know an object exists and I want to supplement it with geographic data. In particular, this was a third-party annotation, so it just made an assertion outside of the content resource itself, so it didn't manipulate the original resource in any way. And I don't have it connected to like a linked data notification, so the Vatican Library is not going to get a notification that I just put out some geolocation information about one of their resources. But those are the sort of things, sort of next step as we get recipes done and as we start to develop around more robust functionality that I could see happening. Anyway, I don't know. I guess, like I said, that's available for you to go play with if you want to, and I suggest that you do. And if you do want a place to go to learn about a few more things, right here, I've linked out to Center for Digital Humanities at SLU, looking at stuff about web annotation, IIIF, and GeoJSON, and where to go look at the recipes for people who are developing real data examples on how to do this. So I don't want to get too far. Something very exciting I made this do now, which I'm super excited I could finish in time. I went through my Rerum, made a presentation 3 IIIF manifest, an empty one. I didn't put any content resources in it. Again, as simple as possible, not very exciting. But I said that I know this is at the Vatican Library, so I've put in the annotation, the GeoJSON annotation into this manifest. And if you see here, if you have a manifest that's done this way and follows the recipe, presentation 2 or presentation 3, although don't, you can provide the manifest to be consumed into draw. Whoop, not annotate, that's not right. So see here, this is my geographic annotation example manifest, that one I just showed you. So what this does is actually consume the manifest and pull the GeoJSON out of it and draw it, which is neat because that's a IIIF resource type, right? That was a manifest, that was a presentation 3 manifest. And since it followed IIIF and it followed most of the script I already had to consume manifests, it was easy to go in and find that annotation and then say, now it's GeoJSON, just pull that out and feed it to Leaflet because that's what Leaflet's looking for. And that's sort of the point, right, is to do a data structure that allows you to have that workflow. I don't want to go too long, so I'm going to maybe clip myself here a little bit. So what this means sort of for the community is that now we're starting to get real technical examples. We're starting to develop things like recipes. And here's a recipe we're working on right now for how to make geographical assertions. Nope, this is the wrong one. In IIIF using annotation. Nope, 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 sorry, I did the wrong one. Sorry, everybody. Oh no, I don't have it. I must have had the wrong one the whole time. Anyway, in the recipes group, there's a recipe there that's starting that sort of walks through and gives you an example on what that manifest might look like. And here is that actual manifest as it stands right now. You can see it's got like Jekyll variables and stuff in it so that it actually has a preview page that looks nice, which I just can't seem to show you right now because I'm failing. But rest assured it's up there, and I'm sure we'll be able to share the link with you if you want to see it. And like I said, here's the actual manifest object itself. You'll see down here inside of a canvas, I'm actually targeting an image segment that has the word Paris and doing one annotation to say that is the word textual body Paris, and another one to say Paris, France by these coordinates. Again, a very simple example, just with points. You know, I'm not drawing polygons or anything in here or defining regions. I'm just geolocating to a point. And then once this moves through maps, through the recipes group, we'll be able to start to develop more complicated recipes. I can imagine ones like something very near in the future, spatiotemporal assertions, right? Of things that not only geolocate you somewhere in the world, but also have the temporal assertion to say time. So you can have things like timeline views or IIIF supported timeline views. We're not quite there yet, but I'm sure we're thinking about getting there. And then obviously IIIF isn't the only people in the world doing this, and I know Bert's gonna kind of go over some more complicated examples and some other institutions and groups working on stuff, but just to show you an example, there's Maps for the Web coming up in, when was that? I think fall of this year, where they're still looking for people who want to do presentations or looking for position papers. You know, just the geospatial realm is just hot in the world right now. It's something that has developed naturally with humanities data because, of course, it's data describing humans and the things they interact with. How can you not include time and space in that description? There'd be no good way to describe that data very well without those realms. Just like it'd be tough to describe a book without, you know, X, Y coordinates to say, you know, what size is it, how big are the pages. It's important information to have that's just natural to what it is. So I think I'll stop there. I was trying to do about 15 minutes. I could have more, but I think Bert's going to get into some real good examples in like complicated geometry that I'm excited for you to get to look at, and I'm excited for me to look at. So I'm going to hand it over.
All right, it's my turn now. All right. Hi. Yeah, I think I was supposed to go first, but then I had the old version of Zoom, but now I have the brand new one, so I'm here. So how does this work? Share screen. Exactly. Yeah, so I will also try to talk for 15 minutes about some efforts to try to use IIIF together with georeference maps. So yeah, just a short little intro about myself. My name is Bert Spaan. I live and work in the Netherlands, but I also worked for the New York Public Library in New York City a few years ago, where I worked on the New York City Space-Time Directory, a 2-year project. And in that project, I worked with all the collections of historical maps that NYPL has. They didn't have IIIF support back then. Maybe they do have now, I don't know. So unfortunately, many of the tools that me and my colleagues then worked on were made just for the library's collections and not for anything else. We were in this little research group called NYPL Labs, which doesn't exist anymore, unfortunately. Anyway, I'm back in the Netherlands now, but still trying to work with maps, historical maps, and georeferencing. So maybe 10 years ago, maybe even a little more, the New York Public Library commissioned a project called MapWarper, which is an open source, web-based, Ruby on Rails georectification platform for maps. The library used it for its own collections of maps, but other institutions have copied it and adapted it and are using it for their own collections of maps. And it's really an amazing tool, just a little old. Here's an animated GIF showing the highlight of the user interface. So what it does, it takes a map from the collection of the library. It doesn't use IIIF, but the library has or had back then another way to get tiled access to their maps. So what you do first, you place control points first on the original map, so in pixels, and then on the world, so in geospatial coordinates, and then you mask the map, so you remove all the non-cartographic material from the map, and then it produces geospatial files such as geotiffs, WMS, or tiles, and other geospatial formats also, and it also allows you to stitch different maps together. So it allows you to take a whole atlas with, let's say, 100 pages from a borough in New York City, and you georeference all of them, you mask all of them, and then what it automatically does, it stitches all of them together, so you get one big map consisting of all the different pages of an atlas. So you can use that in QGIS or Google Earth or wherever you want to use this or see this historical map, and you can start doing historical analysis and start doing other digital humanities projects using those georeference maps. One of the projects that came after is the New York City Space-Time Directory. This is the project I was hired for. And this project tries to combine all historical data sets that the library was working with and turn them into a new digital historical atlas of New York City. One of the projects that we were working on then, this is made by Mauricio Goraldo, one of my colleagues back then. It's Building Inspector, and it takes maps, georeference with MapWarper, and it starts to do all sorts of transcriptions on top of them. So you can see here, one of the views of Building Inspector is transcribing historical house numbers and addresses from those georeference maps. And you can start to see what possibilities will arise when you do this for the whole city. You can create a whole historical geocoder with historical house numbers, historical street names, historical building locations. And if you combine that with, let's say, city directories, you can start making maps of where people lived and what their occupations used to be 200 years ago. And all of those things we pioneered with in the Space-Time Directory project. We made all sorts of little prototypes showing the possibilities of this data. But again, as I said, they're all pretty library specific or NYPL specific. And we didn't have IIIF back then. So many of the things we worked on then are not supportable as we maybe wished they would be. This is another project I created. It's called Maps by Decade, and it's really a search interface viewer where you can see all the maps that have been georeferenced with MapWarper, and they are combined in one single user interface, and they allow for a really easy way to find maps of a specific time and location in the city. So you can just click or point to your neighborhood and select a certain area, and you can find all the maps for that specific point in time and place. And because MapWarper allows for really precise masking of historical maps, you can really very detailed, almost by the block, find maps that depict the actual very area of the city that you're interested in. So it doesn't just use bounding boxes like many online georeferencers do, but it goes a little bit further, and it takes it allows you to find only the maps that you're really interested in. So again, all of those beautiful open source tools still exist, but some of them might be a little old by now, and I'm constantly looking for ways to bring many of the things that me and my colleagues worked on back then, and take them a little further, and try to use TripIF so other institutions around the world can also start using them. And today, as far as I know, there's still not really easy, good open source way to georeference maps or historical maps. There's a few proprietary tools, there's QGIS, there's a few desktop tools, but none of them is easy or fun or open source, or allows for collaborative editing of historical maps in a way that works over multiple institutions. So that's really my aim for this year, is to work on something like this that other institutions can use, and use TripIF and web annotations to create the data you need to rectify or reference in the historical map. And last February in Stanford, or was it March? I think it was February. A bunch of people came together at Stanford University for georeferencing, and in 2 days there was a workshop about TripIF and maps, and we worked on a draft data specification for web annotations for georeferencing, and we worked on a small prototype that would create those annotations. This is really the workflow. So everything starts, of course, with a repository of TripIF maps. They can be historical maps, but they can also be modern day maps. It doesn't matter. And there's really only two things you need to properly georeference a map. So first of all, it's a collection of ground control points, or GCPs. And this is a mapping between pixel coordinates and geospatial points. And those points are then used by an algorithm to do some mathematical transformations between the pixel coordinates and the geospatial coordinates. GDAL, for example, is software that does this for you. There's different algorithms, and they all produce different results depending on what kind of map it is. Usually, if the map is not too old, you maybe need 3 or 4 control points to specify a correct transformation. But when the map is older and less precise, sometimes you need tens or maybe even almost 100 points to correctly transform this map to geospatial current day coordinates. And then, and I mentioned this before also, is a pixel map with which you can remove the non-cartographic material from the image. So you can remove the border and the legend and inset maps, for example, or anything really that doesn't consist of cartographic material. Then you feed this into some geospatial software like GDAL, which is an open source geometric spatial algorithm library. So this software really takes the transformation that you specified. It takes the original image and it does some math, and you end up with a geotiff or a WMS or tiles or whatever you specify you want. And also it can produce a geospatial file with the mask transformed to geospatial coordinates. And of course, if you have those two things, then so the geospatial image and the geospatial data, you can start building geospatial indexes and viewers for the web, or for desktop geospatial software, or for geospatial databases like PostGIS. And this is a screenshot of the prototype I'm working on now. Hopefully the Delft University of Technology in the Netherlands will commission me to finalize this to a prototype that they will start using for their collections of maps. But it will be open source, so hopefully I can find more other archives and libraries around the world that are interested in this, and I would love to talk to people. that have collections of maps and that want to dereference them in a crowdsourced way. Anyway, here you see the step of georeferencing. So you place control points left on the original scanned map. Here it's a map of Stanford, Palo Alto actually. And then on the right, you see OpenStreetMap, but it can be Google Maps. It can be anything really that has modern day geospatial coordinates. And then you create the mapping by placing first a point on the left and then a point on the right. And you can also use this tool to create a mask. And then we worked in Stanford, and for the last week I've been working with Bryan to finalize this first draft of a web annotation data model which consists of all the important parts you need to do the map transformation. So let's start with, so it's really an annotation page, so it consists of 3 annotations. The first 2 are drawn by the users in the crowdsourced georeferencing tool, and then the third one is generated by GDAL. So you here see the collection of control points. So it's a geoadjacent point, so geospatial coordinates, and then every point has in its properties an XY pixel coordinate in the original map. And you can repeat this for as many control points as you have. And then the second annotation is the mask in pixels. So it's really a polygon, pixel polygon, so just a list of pixel coordinates. And the more complex the polygon is, the more points there are in this annotation, of course. And then the third annotation, which is the annotation that's generated by GDAL on the fly. If you changed one of the 2 other annotations, it's a GeoJSON annotation with the mask that you specify the pixels, but then by using GDAL and the ground control points turned into geospatial coordinates. And I have an example of that in the next slide. And I also am experimenting with the SVG selector to specify the pixel polygonal portion of the original TripIF image. So the annotation knows to which part of the image it belongs. And of course, one single scanned map can have multiple maps on them. For example, you can have a page with 2 different maps on them, or maybe there's inset maps on a single map. So of course, then in a single TripIF resource, you can have multiple maps or multiple sets of annotations. So one thing that's missing from this should be a way to link from one annotation to the other, maybe to specify that one pixel map annotation belongs to another geomask annotation. That's the only thing that I think is missing from this. This is a screenshot from geojson.io, really simple web-based GeoJSON editor, where you can see 2 GeoJSON files visualized. First, so the rectangle is the transformed pixel map, but then in mask, but then in geospatial coordinates, and then you can see the 3 control points. And so I'm working on a web interface for crowdsourced map georeferencing and some serverless functions that generate tiles or geotiffs or those geospatial masks on the fly if you submit the data, the annotations to them. So that's really the goal, to use TripIF and to use web annotations and to hopefully create ways that allow multiple institutions to together work on their collections of maps and create annotations in a crowdsourced way, and also create viewers that will allow you to search for maps, not just in one institution, but over many institutions. I guess this was it. So yeah, here's a few links. You can email me if you're interested in this. We can view the presentation again with a little link. And then now Bryan was supposed to go next, but he already presented. So yeah, that was my little presentation.
Thank you, Bert.
Thanks, Bert.
It looks like we have 1 question in the Q&A window from 2 now. Virginia asks, is there support for georeferencing a historical map not based on coordinates, but on place names? So for instance, Paris always points to the city of Paris, even if the map is not corrected to modern day geography. suppose, Bert, that might be a question for you.
Yeah, Bert, you want that one, or you want me to go for my understanding?
Yeah, I can start. Yeah, I think, of course, that will be, I think, pretty easy, and I don't think you need any of the annotation models that I presented. I think it's more Bryan's stuff that you would need to include. But of course, if you would include, I think annotations like this can be a start, because it can be really helpful. Let's say you first do a arithmetic pass of all your maps in your collection, and you start looking at the titles, and then you code them. You add some geospatial information that you get back from the geocoder, and you start adding geospatial coordinates using the ways that Bryan presented. So they give you a good starting point for a tool like mine, because they might already put the starting point of the map on the right location. So you don't have to zoom in all the way from the world to Paris, because the map already has some metadata attached to it that it is in or around Paris. So I think annotations like this might not be precise enough to do historical research when it comes to knowing really in a really detailed way where in the world the map is, but they can be a good starting point for further georeferencing.
Yeah, and to keep on that, I mean, there's a specific example of it. I can't see it in my brain, but I know using the web annotation model, the body and target sort of method of how you can get fragments of anything and relate it to fragments of anything. I could see, you know, that there exists an annotation that has the body of, you know, a containing area for Paris, or a point in Paris that is an array that's connected to different, maybe slightly different georectifications that exist in the world, which I just learned is something the world does. It's goofy where I come from this, because I don't work on map content. So like a lot of the lingo and a lot of the things, you know, I didn't really know. And to learn that, you know, 0.1212 in my georectification may not be 0.1212 in a different georectification. That one blows my mind. But I know it can be done, especially like, because, you know, the body of the annotation, like I said, could be arrays that targets the text string Paris, or a node that represents a permanent URL for Paris. But as that comes standard to a processor to know, to look for, to understand, that's where things get tricky. Right now, we're trying to really sit at the level of trying to do things we know processors can understand, like put georectification on it and draw the SVG or draw the point. But as far as connecting outside of points, we haven't quite started thinking about that yet.
Great. So Stace has a question, also I think for Bert, about, he asks, can you talk a little bit more about how you're thinking of generating tiles on the fly with these serverless services that you're talking about?
Yeah, I haven't really figured that out yet completely. So I have created this one little Docker image that runs GDAL and does basic, run some GDAL commands, like generating GeoJSON polygon when you supply a set of, a pixel mask and a set of ground contour points. I think it can also just create a GeoTIFF. Currently I'm using Google Cloud Run or something it's called. It was really easy to set up. I've never done this before, so I don't know what is best. Also, I don't know if running GDAL in a Docker container is the smartest thing to do. Maybe I should just dive into the source code of GDAL and maybe I realize that it's not too complicated at all. But so far this works just fine. Of course, yeah, when you run something like this, it produces a set of tiles or GeoTIFF, you need to store it somewhere. Yeah, this is all pretty new to me, running serverless cloud things like this. So I guess I have to figure out how this works.
Great. The next question is from Mattis or Matisse. Sorry if I didn't pronounce your name correctly. Bert, it seems like you really know how to use your tools. How long does it take you to rectify a vintage map to the level that you're happy with?
Well, I'm happy pretty quickly usually, but I had some colleagues at the library, in the New York Public Library, and they organized sort of map warping afternoons or workshops, and they had people coming in, and some of those people really took the job serious, and they went in, and they weren't happy if it wasn't to the meter almost. But the way I see it, you can always start with something, and then somebody else can improve it. And of course, depends on what you need the map for, and if it's just to get a sense of what an area looked like in the past, then maybe being maybe 10 meters off or 100 meters off doesn't really matter. But then if you start to use it for maybe archaeological research, then those distances, of course, are enormous. So for me, it was just a fun little, I really liked doing it. So I really spent a large amount of my time when I was in New York just georeferencing old maps. And it got me to learn a lot about the city. And always when I georeference a map, I wanted to go to that part. So I got my bike and I biked there. So the way I see it, it should be, so my ideal georeferencer should be some web-based interface that makes it really fun to georeference maps, and makes it so that you don't have the idea that you can do it wrong, so that everybody helps each other. Because you can learn so much. And of course, there were some parts of New York City that have changed completely over the years. So it was really difficult, and I really had to do some really historical research to find out, because everything changed. The blocks changed, the street names changed. So then sometimes it took me hours. But then other maps I could do in a few minutes. It really depends on the map and what you want to do it for. But I just hope people find it fun, and I hope the user interface I work on will make it fun for people to do this.
So there's a follow-on question there, I think, about the sort of technical details of how that transformation is accomplished. What kind of distortions or transformations do you support, or do you use bending, twirling? Can you do 3D? Things like that.
Yeah, I think GDAL out of the box supports a few different algorithms to do the map transformations. I forget the names. So currently, I think supporting that is easy, because I'm just running GDAL, so I can just support everything GDAL supports. I guess there's more ways to do it. I don't know enough about the math yet to give a good answer.
Yeah, but I can imagine sort of at a higher level, at a really basic concept, if we have sort of maps, being drawn inside of canvases, we should be able to at least absorb the canvas level manipulation things that IIIF is capable of. I know that certainly doesn't cover everything that is for a map, but it's sort of some freebie things we can get out of that, or even something like the image API, although I'm not sure exactly how that relates back to maps and coordinates. I don't know if that'll quite work out, but there are ways through IIIF to do some basic manipulations to start with, and that we might focus on first before we get into deeper stuff like that.
So that's all the questions I see in the question queue here. Bert or Bryan, do you have any final thoughts? Or
I do. I think I see one more question.
Oh, is there one more?
From Keith.
Oh,
I don't know if
yeah.
you see it. Maybe he just asked
yeah, there was two more. I didn't scroll down.
Yeah, there you go.
Okay, thank you, Bryan.
No problem. No, let's get those.
Yes, absolutely. Keith asks, are these georeferencing models intended to be used for reprojection on the fly, or for generating derivative output files like geotiffs, or for both?
Yeah, I think both. So I think, for example, Clocan's tool, georeferencer.com, does on-the-fly georectification in the browser. So I'm sure they took the same algorithms that GDAL is using, and they ported them to JavaScript, to WebGL, and they're running them in the browser. Maybe it doesn't use the highest resolution IIIF image possible. So I guess then you have to, maybe that's just for viewing it in a browser when you're doing the referencing, and then later on the server, you create a higher resolution version. So I think for both.
Yeah, I can, yeah, I mean, even in my demo, when you're making the point, as you change those points, the dot that's there as your preview sort of changes with it. And that's me having those coordinates in that object in the background. And so making stuff on the fly, or whether it's already in some permanent state, it's more about the fitting the presentation API for the representation of that resource within you know, the scope of IIIF within the standard. So yes, is the answer to the question. I think both.
The next question is, do you beat 15 minutes on average? I think maybe that refers to.
No, this is probably about the fourth time I've rehearsed this, and they were all over 15 minutes. And then I think my saving grace was getting to go first and getting, it threw me off a little bit, so I felt like I needed to go faster.
You have a lot of good information, Bryan.
Yeah. So I mean, it's been crazy for me because following, you know, it's the Maps interest group, it's the Maps technical specification group, it's the recipe group, and you know, every minute little thing, getting it right and getting recipes out the door. I mean, getting into JSON LD considerations, JSON LD 1.0 versus 1.1, and restrictions that might cause, and do we even want to use GeoJSON LD? Maybe we just want to use flat GeoJSON, or maybe we want to use, what was the other one? JSON literals, I think it was something else I heard we might be able to use that somebody asked me to make an example of. And then not only that, so these and everything we talked about was presentation 3, but there's also presentation 2 out there. Presentation 3 really just started to become official. And so, you know, we've made recipes along the way that show how to do it in presentation 2 with the annotations, and in presentation 2 with the service. And in presentation 3, we want to maybe promote an extension so that we can put geospatial data directly on resource types instead of having to do it through the annotation model. There's just so much going on with it, and as far as what we're going to use it for, what it will be completely intended to do, we don't have an exact answer yet. I don't think. That's how early the stages are with this. So it's a lot.
Yeah, there's definitely a lot. And that previous question, just to clarify, there's a clarification here. The question was about actually how long it takes to rectify a map. So is 15 minutes enough time to kind of do that transformation process and generate a geo-rectified map, or does it just depend on what you're working on?
Yeah, I guess it depends. But no, some of them you can do in I don't know, 20 seconds. Yeah. So maybe this makes me think that maybe the tool should be really more like a game. There should be a high score list too. I'll work on a high score list.
It's a great idea.
I like it.
Let's see who's the
We'll
fastest.
make a repo for it.
Yeah.
Okay. Now I've checked. I think we are at the end of our question list, unless someone else has something else they'd like to add. Well, thank you, everyone. Thank you to Bryan and to Bert for giving us a presentation and demoing their work. This was a great session.
Good.
Thanks for everyone.
Glad to be here.
See you at the next one.
Thanks, folks.
Yep.
See you at the next IIIF week event.
Absolutely.
Bye-bye.
Take care.
Bye.